Bun is an all-in-one runtime, package manager, bundler, and test runner for the JavaScript ecosystem. That means that it's one tool that replaces 4, and it's fast. Bun was built from the ground up with Zig and Apple's open source JavaScript core engine, making it 4 times faster than Node.js. And yet, this is just one of the reasons to love Bun. Here are 9 more. With Bun, you can write and run basically any JavaScript, but it's especially powerful for servers. You can set up an API with the bun.serve command. We pass in a routes object that maps each route to its response, which can be static or dynamic. It's also trivial to serve HTML. Just import your HTML page and return it from a route. You can similarly serve other files like images. Congratulations, you now have a full-stack web server that automatically handles TypeScript transpiling, JS and CSS bundling, TLS, and hot module reloading. Oftentimes, you'll want to parse different content files to affect what you're serving. For example, if you have a blog, you might want to store your articles as Markdown. Rather than reaching for a CMS, you can handle converting Markdown to HTML directly in Bun using bun.markdown. Here, we're loading the Markdown file, converting it to HTML, and then serving it from our routes. You can also do simple templating with HTML rewriter. In our HTML here, we have a paragraph with the ID content. In our TypeScript file, we load in that HTML as text, then we create our rewriter object, which finds anything with the content ID and changes its inner content. We then transform our template and can serve it from our routes like before. The end result is serving a modified version of our index. You can use this rewriter statically or dynamically if you wanted to, say, serve different content to different users. Bun comes with built-in parsers for YAML, JSON, and TOML files, which is convenient for storing things like configurations. Now, file handling is great, but what if your application needs to store larger amounts of or more complex data? Well, lucky for you, Bun comes with built-in bindings for SQL, Redis, and S3 compatible stores. These provide direct APIs for interacting with your database, cache, or object bucket, respectively. I'll walk you through an example with Redis, an in-memory key-value database which is ideal for low-latency read and writes. Here we're making a simple but robust rate limiter that lets users send 3 requests every 60 seconds. In our rate limit function, we first increment the value associated with the user's IP. If the value of the count is now 1, i.e. this is the first request the user is sending, we set that key to expire after 60 seconds. We then return whether the count is above the limit. If the user sends more than 3 requests within the window, we know not to process their request, preventing them from spamming our services. Once the window has passed, the key expires, and we can create a new window for the users on their next request. Not only is the developer experience here great, but, like all things in Bun, it's crazy fast too. But supposing you don't want the hassle of managing a separate database, you can always use Bun's SQLite driver. This lets you run a SQLite database right on your server or with your CLI app. Here we're storing our database in a local file called data.db, but you could also run it in memory. If you have a database, you probably also need some kind of authentication layer to make sure a user really is who they say they are. Now, you could do this with a third-party provider or using an auth framework like BetterAuth, but since we're in Bun, it's not too difficult to implement this ourselves. Firstly, Bun makes it easy to generate v4 or v7 UUIDs when new users sign up. And we can handle password hashing and verification with bun.password. We can also easily manage user sessions with Bun's methods for setting cookies. It's as easy as setting a cookie on the request. The modified cookies are automatically applied to the returned response. And so, in not much time, we've set up simple authentication for our app. Now, maybe your site needs access to third-party APIs. Well, you can send HTTP requests with Fetch. For example, you could use this to hit the YouTube API and make sure that you're subscribed to my channel. And if you're not, you should really take actions to rectify the situation. You can also use WebSockets for persistent, real-time, bidirectional connections with your clients. Here, we've got the server side of a simple chat app. When a request is sent to the chat route, the request is upgraded to a WebSocket connection. And when a WebSocket is created, we subscribe the client to the chat. When the server receives a message over the WebSocket, we publish it to all subscribers of the chat. And then, when the WebSocket connection is closed, we unsubscribe the client. These WebSockets can be used for everything from live location tracking to online multiplayer, and they're up to 7 times faster than they are on Node. But maybe you want access to lower-level networking primitives. Bun's got you covered there too. You can easily use TCP and UDP to create your own application layer protocols. You can also resolve DNS records manually with Bun's DNS module. What if low-level networking isn't enough, and you need access to other low-level primitives? Well, you can always write code in a low-level language like C, Rust, or Zig, and then call it from Bun using Bun's Foreign Function Interface, or FFI. Here we have a function to add to arrays in C, and the bindings to load it in Bun. Using C for this made array addition 3 times faster when I tested it with optimizations. One caveat is that you always have to recompile the low-level code into a dynamic library after you change it. But if you're just using C, you can actually compile your code directly in Bun. Bun embeds TinyCC, which is a fast and lightweight C compiler. You just import your C source code directly and then run it through the cc command, and it will compile it at runtime. Now that you've implemented your awesome program, you can compile it into an executable that you can run on your server or share with your friends. When doing so, you can enjoy the 200 times speed improvement over Rollup and Webpack. You can build your program in the CLI with bun build, or do it from JavaScript, which is useful to do if you have a complex build process. You can also generate a standalone binary with the compile flag. This is an awesome way to write cross-platform CLI apps in a high-level language, as long as you don't vibe code the entire thing and do your terminal UI with React. Before you ship or deploy your code, you should probably test that it works the way you intended. Luckily, Bun has you covered with their fast, built-in, Jest-compatible test runner. Once you've written your tests, you can run them from the shell with bun test. You can pass the watch flag to rerun tests automatically when code changes, or use the concurrent flag to run your tests in parallel. And finally, we've written, tested, and deployed a fast, full-stack web app with dynamic content, a database, authentication, and our own networking protocols and low-level interoperability. And after all this, we haven't even needed Bun's package manager, which has full feature parity with NPM, Yarn, and PNPM, while being at least 10 times faster. You can also use Bun's package manager in any existing Node.js project to speed up package installation. Hopefully it's pretty clear why Bun is one of the most beloved projects in the JavaScript ecosystem. If you're interested in seeing some more full-stack development, you might want to check out my video where I made a web API to get around Apple's hardware lock on Apple Intelligence. But for what it's worth, the YouTube algorithm thinks you'll enjoy the second video on your screen more. I've got some more videos planned on TypeScript and web development, so be sure to subscribe so you don't miss them.